Hello again, math students. Today we are going to be going through all of our Chapter 2 review so that you'll be ready for the test tomorrow. This presentation is going to be going right through your worksheet. So if you're at home working on this right now, you should have your worksheet out and be doing this right along with the video. So these first 4 questions have a picture of these 2 houses that are identical, which means that they're congruent. They're exactly the same size and the same shape. So it says on here, the first question says, what is the length of side VZ? So VZ is right here, and there's no marking there at all. However, we know that it matches the other house, which would mean that it's going to be 40 feet. Number 2 says which angle of the shape on the right, VWXYZ, corresponds to angle E. So angle E is right here. In the other house, the one that matches up with it is right there, angle V. And we need labels on every one of these. In this one, the label is really just that angle mark. That's angle V. In number 1, the label was the feet. In number 3, it says that side GF is congruent to side GH. So we've talked about using those tick marks to show those 2 are congruent. I want to know how long side GF is. Well, it doesn't say how long GH is, but again, over here, the corresponding side is going to be 22 feet, which means that this is 22 feet and that this is 22 feet. And I want to know the perimeter of the one on the left, EFGHJ. Now, it's nice that I just wrote in those 22s because to find the perimeter, I have to add up all of those side lengths. So if I would add 22 and 22 and 13 and 40 and 13, that's going to give me 110 feet. These 4 questions, there's 4 options. There's going to be one of each, okay? So in number 5, when I'm looking for what happens to go from this original W to the one on the right, that is clearly a rotation. It's turning. I don't have to answer anything else about it, but that's clearly going to be a 90-degree clockwise rotation. Number 6, the smiley face from the one on the left to the one on the right is getting bigger. That's called a dilation. And again, specifically, that would be an enlargement if we're going from the left one to the right one. Number 7, this is a reflection, right? If I had my line right there, not quite lined up, but close. And then number 8, this doesn't turn, and I can tell because of the handle. So this is not a rotation. It's not a reflection. It's just sliding up and to the right or right and then up, which would be a translation. In number 9, I have a rectangle. I've got the vertices there. And then I want to follow the rule for the translation, which is just saying x minus 2, y plus 5, which means 2 to the left, up 5. And then I'm going to do a 90-degree clockwise rotation. So this is totally up to you if you want to use the graph. It does say use the graph if necessary. In my opinion, the graph is just kind of your workspace. So on a test question, I'm not going to be checking your graph. Some students are perfectly fine just using the rules and going ahead and following that. I personally kind of like to just do the rules. So for me, what I would do here, using my first one, the translation, remember this is saying I'm going to have x minus 2 and y plus 5. That just means I'm going to subtract 2 from every single x. I'm going to add 5 to every single y. So if I'm not graphing this, I could start every one of these with a parenthesis. I'm going to subtract 2 from each of the x's. So for A, 2 minus 2 is going to be 0. 5 minus 2 is going to be 3. 5 minus 2 is 3. And 2 minus 2 is 0. When I add the 5 to all of those, negative 1 plus 5 is going to be 4. And again, 4. -3 plus 5 would be 2, and -3 plus 5 is 2. Now, if you're good with that and that made sense, great. You don't have to graph that at all. I'm going to do the whole thing just with the ordered pairs with the rules, and then I'll go back and I can do this with the graph as well. For the rotation, because this is a 90-degree clockwise rotation, here's what we do for a 90-degree clockwise. What we're going to do is we're going to change the sign of the x, and we're going to change the order. So the y is going to go first, and then we're going to change the x. So from the a primes, we're going to put the y first, then we're going to change the sign. Well, it's a 0. That doesn't change. For the b prime, put the y first, change the sign of the x. Put the y first, change the sign of the x. Put the y first, 0 doesn't change. If you are good with that, that's all you have to do. I'm perfectly fine with that. If you're not absolutely sure, if you want to use the graph, we can start by graphing the original shape. So A is at 2, -1. B is at 5, -1. C is at 5, -3. And D is at 2, -3. So here's my original rectangle. The first thing I'm going to do is move everything 2 to the left and up 5. So let's do that. For A, 2 to the left and up 5. I don't really want to put dots on here. So 2 to the left, 2, 3, 4, 5. 0, 4 is the point that I had there as well. There's my A prime. For B, 2 to the left, up 5. B prime, don't forget about the primes. To the left, up 5, and to the left and up 5. So here is my first image, but now I want to do my rotation 90 degrees clockwise. This one's going to get a little bit messy because it will land on top of the other rectangle that I started with. When I do this rotation, again, you can follow those rules, or you can turn your graph. The problem is that my writing here won't stay when I go to rotate this. So that's not really going to help me all that much on this one. So I'm just going to have to kind of rely on turning my head. If I'm going to turn this 90 degrees clockwise, right now this shape is on the y-axis and it's in quadrant 1. I need it to look like it's moving into quadrant 4, which really means I'm going to turn my head counterclockwise. Point A looks like it's at 4, 0, which is what I have on my ordered pairs. So here is A double prime. B looks like it's at 4, -3. C looks like it's at 2, -3, which is right here, landing right on top of that one. And then D looks like it's at 2, 0. And again, the double primes are really important. That's not something you can just ignore when we're doing this kind of work. Now, looking at the back side, number 10 is asking you to do a 90-degree counterclockwise rotation. This time, yeah, I can actually turn my graph. So let's do this one with paper turning. When I do this, if I turn this so that it's 90 degrees counterclockwise, it's going to look like that. So now I can just write down what my ordered pairs look like. A looks like it's at -1, 1. B looks like it's at -4, 1. And C looks like it's at -1, 3. And again, it does say to use the graph if necessary. If you just need to turn it and write down your ordered pairs, that's fine. If you wanted to use the rule is this. 1 second. The rule is, I'm going to take every ordered pair, and for a 90-degree counterclockwise, we are going to change the sign of the Y and put it first. So for point A, because it was at 1, 1, we're going to change the sign of the y number, that'll be a negative, and it's going to go first, which is what I have. For B, it's at 1, 4. Change the sign of the y, which makes it negative, and put it first. And C is at 3, 1. So change the sign of the y, make it negative, put it first. Number 11 asks the difference between similar and congruent. Similar, remember, just means that it is the same shape, but it's going to be a different size. This is what we get when we have a dilation. Congruent figures means that they are exactly the same size and shape. As long as you don't have a dilation, any of our other transformations are going to be congruent from the original to the new image. For number 12, it's giving us translation notation. I want to figure out what these new ordered pairs are. I purposely didn't give you a graph on this one. I want you to be able to use this translation notation. And again, this is saying I'm going to add 2 to each x, which means 2 to the right, and subtract 3 from each y, which means move it down 3. But again, I would just do all of my x's first. It's easier for me to just focus on one operation at a time. I'm going to add 2 to every x. So the a, instead of starting at 2, is going to start at 4. For the b, instead of starting at -1, it'll be a +1, and the c will be at -1. Now, I'm going to subtract 3 from each of the y's. So -2 minus 3 would be -5. 4 minus 3 would be 1. And -2 minus 3 would be -5. And for number 13, we have a scale factor of 2. We're figuring out this dilation. Because the scale factor is more than 1. I know right now it's going to be an enlargement before we do any of the work anyway. I need to get the ordered pairs. If you want to graph it also, you certainly can. But I want to look at this. Point U right now is at -1, -1. If I have a scale factor of 2, that's going to put it at -2, -2. V, which is at the top, is kind of hard to read, right now is at 0, 1. When I multiply everything by 2, I'll have 0, 2. And W is at 2, 0. Multiply everything by 2 and I get 4, 0. And again, you can certainly graph that if you need to, but it's really not that necessary. All right, and for this last part, it's going to be really important that you read carefully. This says that for part A, use a translation or use translation notation to describe the translation to go from Krypton to Metropolis. I'm actually even going to draw in an arrow saying I'm going there. Okay, it's going left and down. So translation notation says I'm going to take an ordered pair and I'm going to change it because I'm going left. I know I'm subtracting. I am moving left. 1, 2, 3. Subtract 3. For the y, I'm moving down. 1, 2, 3. Subtract 3. There's my translation notation. B says that Gotham City, now Gotham City isn't on my map right now. Gotham City is a reflection of Metropolis. Here's Metropolis. This is what we're talking about. It's going over the y-axis. This one isn't labeled, but this is the y-axis. Right now, Metropolis is 1 to the left of the y-axis. I need to go 1 to the right. So this is going to be Gotham City. That ordered pair is at 1, 1. The other thing you can think about is if you reflect over the y-axis, the x's are going to change signs. And for part C, the transformation from Krypton to Saturn. Again, Saturn's not on here, but Saturn is a 90-degree clockwise rotation from Krypton. So Krypton, I'm going to go 90 degrees clockwise. Okay. Now, I can actually just turn this just like you could turn your paper. So when I turn this 90 degrees clockwise, now I know that arrow doesn't make any sense, Krypton looks like it's at 4, -2. So that's what I need. I need this to be at 4, -2. You can use the rule if you'd like, or you can just do your paper turn. Now, the test is going to be tomorrow. If there's any part of this that didn't make any sense, please let me know. But I hope you're feeling ready.